Imagine the thrill of discovering a new Earth-like exoplanet, only to find out it's as barren as a desert rock. That's the reality for JJ3929b, the latest exoplanet to have its hopes dashed by the James Webb Space Telescope, JWST. But here's where it gets controversial. While some scientists see this as a setback, others argue it's a crucial step in understanding the cosmos. Let's dive in. As missions like Kepler and TESS uncovered more rocky exoplanets in recent years, the scientific community eagerly awaited the launch of the JWST. This powerful space telescope is designed to gather infrared spectra of exoplanet atmospheres, a critical piece of the puzzle in understanding these distant worlds and their potential habitability. The JWST has certainly lived up to its hype. It has studied numerous exoplanet atmospheres and even detected some intriguing potential signs of biological activity. However, these findings are far from conclusive, and this is the part most people miss. The JWST's capabilities go beyond just detecting atmospheres. It can also provide insights into the composition and dynamics of these atmospheres, helping us understand the conditions on these planets. One of the JWST's latest targets was JJ3929b, a rocky exoplanet discovered in test data in 2022. The initial analysis confirmed its planetary nature, with a mass and radius similar to Earth's. Earth-like planets naturally grab our attention, don't they? They represent the best candidates for hosting life as we know it, but the JWST's recent observations of JJ3929b have poured cold water on these hopes. The results, published in a new paper titled The JWST Rocky Worlds DDT Program, reveals JJ3929b to likely be a bare rock, suggest that the planet is essentially a bare black rock. The lead author, Kyo from the University of Chicago, and their team used the JWST's Director's Discretionary Time DDT program to study JJ3929b. This program combines observations from both Hubble and JWST to search for atmospheres on rocky exoplanets orbiting red dwarfs. Red dwarfs are a popular target for astronomers. They make up about 75% of stars in the Milky Way, so they likely host the majority of exoplanets. They're also long-lived, giving life plenty of time to develop. Plus, their habitable zones are small, making transits easier to observe and atmospheres easier to study. The new observations refined JJ3929b's mass, size, and surface temperature, which matches that of a bare black rock. The researchers ruled out CO2-rich atmospheres thicker than 100 millibar, suggesting that JJ3929b has lost any significant secondary atmosphere. They also supported the cosmic shoreline hypothesis, which posits that the presence or absence of a secondary atmosphere is largely controlled by the cumulative XUV radiation a planet receives over its lifetime. So, what's the cosmic shoreline hypothesis? It's based on the fact that X-ray and UV emissions from stars can heat planetary atmospheres, causing atmospheric particles to gain enough energy to escape. This process, known as photoevaporation or atmospheric escape, can strip a planet of its atmosphere over time. The researchers compared JJ3929b to 3 versions of the cosmic shoreline and found it on the airless side of all 3. In other words, JJ3929b has likely lost any original atmosphere it may have had, as well as any atmosphere replenished by outgassing. Compared to other presumed bare rocks like TRAPPIST-1b and c, JJ1132b, and JJ486b, JJ3929b is the farthest from the shoreline, making it highly unlikely to sustain a CO2 atmosphere. Now, you might be thinking, that's disappointing. And you're right, it is. But these results still have scientific value. The JWST will likely revisit JJ3929b and many other rocky worlds in the future. Together, these data will build a statistical framework for atmospheric retention, surface composition, and XUV-driven erosion on these small planets. This will transform our understanding of how they form, evolve, and either keep or lose their atmospheres in the intense radiation environments of their host stars. So, is GJ3929b a dead end or a stepping stone to greater understanding? That's up for debate, but one thing's for sure. The JWST is rewriting the book on exoplanet atmospheres, and we're all along for the ride. What do you think? Does this setback for GJ3929b dampen your hopes for finding life on other planets? Or does it fuel your curiosity to learn more? Share your thoughts in the comments below.